Welcome to Spring LIB.
We're asked to solve the problem in example 4 of this section if the river is 5 kilometers wide and the point B is only 5 kilometers downstream from the point A. So again, drawing a diagram like in example 4, we have a triangle with 3 points A, B, and C. It's a right triangle. And then we have another point D on the side opposite of A. And now we have the distance from A to C is 5 kilometers. And the distance from A to B is 5 kilometers. Sorry, B is only 5 kilometers downstream from A. This means the distance from B to C is 5 kilometers, not from A to B. Now let's call this mystery distance from D to C X. So X is the distance downstream from the point directly across the river. Now the running distance, this is the length of dB. Which is 5 minus X. And the rowing distance, once they're on the river, this is the distance from A to D. Using Pythagorean theorem, this is the square root of 25 plus x squared. Also, our rowing speed is 6 kilometers per hour and running speed is 8 kilometers per hour. So it follows the total time running and rowing, which I'll call T of x. Well, this is our rowing distance divided by our rowing rate, 6. So we have the square root of x squared plus 25 over 6 plus the running distance, 5 minus x over the running speed, 8. And it's clear from our picture that the domain includes all x between 0 and 5. Now we're trying to minimize this time, so we'll take the derivative of t. We want to solve t prime of x equals 0, so we get t prime of x equals, this is 1/2 times x squared plus 25 to the negative 1/2 times 2x over 6 minus 1/8. Which is equal to x over, or x, over 6 times the square root of x squared plus 25 minus 1/8. And again, we want to set this equal to 0. So this is x over 6 times the square root of x squared plus 25 equals 1/8. So we have 8x equals 6 times the square root of x squared plus 25. Solving this radical equation, you can square both sides. Eventually, you should get 7x squared equals 225. And so x is equal to the square root of 225 over 7, which is approximately 5.67. And recall that the units are in kilometers. Now the critical number that we have, this is outside of our domain from 0 to 5. To find the absolute min or max on a closed interval, it therefore follows that our answer must be at the endpoints. So let's find t of 0 and t of 5. T of 0, if you plug this in, is approximately 1.46, and the unit is in hours. And T of 5, this is approximately 1.18, and again, the unit is in hours. Looking at these two times, we see that the time is shorter when x equals 5. And so T has an absolute min at x equals 5. Therefore, what's the man's strategy to minimize the time? The man should row directly from point A to point B.